Video is going to be about an easy way to determine whether a rational number is in the Cantor set. First, I'm going to say what the rule and what the steps are to determine whether it's in the Cantor set, and then I'll draw some pictures so that you can see what the rule is actually doing. So if you have a rational number a, and then you multiply a by 3, a should be between 0 and 1. So that it might be in the Cantor set, we don't know. So it's in this interval, so it has a chance at least at being in the Cantor set. And then we multiply it by 3. If 3a is in the open interval 1, 2, then this implies that a is not in the Cantor set. But if 3a is not in the open interval 1, 2, then it might be in the Cantor set. So what we're going to do if we're in this situation where 3a is not in the open interval 1, 2, is we're going to take whatever 3a is, and if 3a is less than 1, so if it's on the left side of this interval, then we're going to multiply it by 3 again. And if it's greater than 2, so if it's on the right side of the interval, we're going to subtract 2. So it's best to see an example here. So take the example 1/4. So if we have a as 1/4, then 3a is 3/4. And that's good because it's not in the open interval 1, 2. So we're going to take 3/4 and we're going to multiply that by 3. So now we have 9/4. And 9/4 is also not in 1, 2, but it's bigger than 2. So we're going to take 9/4 and we're going to subtract 2. And then we get back to the original number 1/4. And this is how you know that it actually is in the Cantor set, is if you end up with the number that you started with, or with some number that you got earlier in the process that was in that 0 to 1 range. So now let's look at a picture for another example. Now we just saw that 1/4 was in the Cantor set, so we know that 3/4 is also, but let's just take the example so that makes a nice picture of 3/4. So here's the interval 0 to 1, and then here's the interval 1 to 2. And what this rule is doing is it's saying, here's this middle third that we know we're going to delete, and all these things are not going to be in the Cantor set. So let's look at if we multiply the endpoints of this by 3. So 1/3 times 3 is 1, 2/3 goes over here to 2. And so anything that is in this middle set that's going to be deleted, when you multiply it by 3, is going to be in this interval. Sorry, I keep saying set instead of interval. Anything that's in this interval that's going to be deleted is going to end up being in this interval between 1 and 2 when you multiply it by 3. But if we take a number that is in the Cantor set, so let's take 3/4, and then we multiply 3/4 by 3, we're going to get 9/4, which is more than 2. And then if we do 9/4 minus 8/4, or 9/4 minus 2, it's going to take us back to 1/4, back here. And then finally we're below that 1 range again, so we're going to multiply by 3 again. So we have 1/4 times 3 is 3/4. And we're going to end up back where we were. Now let's look at one that's not going to work out so nicely. So set this up again so we can see what's going on. So let's take the number 5/6. I'll do it in red because we know this isn't going to work out. And we multiply it by 3. We get 15/6. Oops, we want that in red. Or I'll do it in black. Okay, so we have 5/6, 15/6. Alright, we're not in that 1 to 2 range. Looking good. But then now let's do 15/6 times 3. Sorry, minus 2. So minus 12/6. Then we get 3/6, and that's going to pop us back into this range, which is not the Cantor set. And then if you really want to just stick to this algorithm, where you're only booting it out when it gets in between 1 and 2, when you multiply by 3, you multiply 3/6 by 3, and you'll get 9/6, and that's in 1, 2. And it's important to remember this is only going to work for rational numbers. If you want to know if an irrational number is in the Cantor set, you're not going to be able to use this process. One thing that you could do maybe is look at that irrational number in base 3, see if there's a pattern, and if the pattern's only containing 0s and 2s in base 3, then that's going to be a sign that it is in the Cantor set. If it has 1s, then it's not going to be in the Cantor set. But this is a pretty easy way to look at rational numbers.